In this video, we'll take a look at how continuous deployment works in objectiF RPM. We'll be doing a deployment for an application comprised of microservices. It's using a technology stack with node.js for implementation, Docker for container images, and Amazon Elastic Cloud. Our example application consists of two services. The first, named Web Service, publishes websites. The second, just called Microservice, deals with specific technical tasks. Among other things, it's responsible for generating a user greeting. The application is already running, but there's a new requirement to make the greeting text friendlier. So our task is to update the microservice and deploy it immediately. First, let's take a look in the cloud. Here we're at Amazon Web Services in Frankfurt. We see that we've got a cluster for the application, and right now there are 2 containers running for each service. Let's start working on the microservice. The architecture diagram reveals that the microservice publishes its interface through a port, using these 2 operations. We want to modify hello, so let's open up the source code. We can do this through seamless integration with Visual Studio Code. The greeting is made up of the string hello and the username from the request parameter. Let's add something a bit friendlier. We'll save the changes, and this time we'll skip the unit test. Now we'll give the modified code back to the source code manager in objectiF RPM. The next step is to generate a new container image. This can be done simply through a function in the context menu of the microservice. The container image will be generated in the local Docker repository. So, does our modified microservice work? We'll test the container in a local Docker domain. Let's start the container. When we refresh the site in the browser, we see that the change is functioning. The container image for our microservice contains everything necessary for running it. So if the container runs in a local environment, we can also run it in the cloud. So now let's transfer the container into the cloud. We just need to click Run Container in Cloud. Let's look at what's happening in the cloud. In a couple minutes, new containers will be activated. Now the new additional containers are also running. A load balancer will distribute the requests. After a while, the old containers will be deactivated. Let's check the result, but this time on the internet. When we refresh the site, we get a new answer to the request. So, this means that the new container with the updated microservice is running in the cloud. Let's take a look at the implementation of the microservice. All corresponding files are managed and versioned in a directory structure. Each service has a directory with JavaScript files for the operations and 2 other important files: a Docker file defining what belongs to the image and gets packaged, and a package.json file defining which node.js modules are necessary. Both files are technology specific. Deployment functions such as generate container image and run container are also to a large extent customized for specific technologies. So what happens if you're working with a different stack or even several other stacks at the same time? In that case, you can replace the deployment functions in objectiF RPM with your own. This is possible because the functions are carried out as script-based extension functions. Here you can see the extension functions for deployment in Amazon Cloud. Extension functions are implemented as RESTful services in JavaScript. Let's take a look at the code for generate container image. For this function, we need certain information from the objectiF RPM repository. All in all, the function boils down to the command docker build. Let's summarize. With existing or user-defined extension functions, microservices can be deployed around the clock, any day, anytime, and as often as necessary. objectiF RPM supports you with a model-based approach and high extensibility.